I'm going to start with a thing I'm a bit more comfortable with, which is Softimage. And so basically the effect, actually, I think I forgot to copy the link for the effect I wanted to do. Let's see. So this is the thing I'm going to look into. Let me put here this streamable. So this is the effect. Basically, it's just some pieces. In this case, there are some cubes with some divisions, but it can be, whatever type of mesh you want. And so the idea is just to show that once one get to know some concepts, it can be reapplied in many places. And so this is a bit of a stunt, of course. There's no great need for me to do this, but actually, this is some way of work that I really enjoy. And if I can find like-minded people, I would be really happy with that. And so for me, nodes, of course, don't replace coding. But to me, since I'm my background is fine arts, so as you can imagine, I had no coding training, and so to me, nodes are really the way to go if I want to. In my case, since I was very dumb and I wanted to do things and I didn't know how. And so nodes allowed me to do that, to basically try and try and try in an inexpensive way. So I didn't have to get to know the SDKs in depth to learn how to code, even though, of course, knowing the logic of programming, it's of course a great benefit. But I didn't, there's no mistypes, there's no, okay, this is what I want to do. And to me, I find it very easy to just change connections and try things and see if this works. Okay, this doesn't work. Let me try something else. And I can have a brute force approach. So I can be dumb, but I can get somewhere because I try a lot and I have a system that allows me to try a lot and fast. So that's why I really like this. So let's move on to what I'm going to do here. And so first I'm going to go into Softimage. So the effect is basically this. So I have an array. I have these little meshes organized in an array, in this case in the x-axis. And so they are spaced in a way that if I turn on, basically the first thing I want to do is I want to put them all in the origin. And so to do that, I need to get a unit value, a single value for each. In this case, you could say, well, why don't you go with the connected geometry? So for example, in Houdini, I could check for connectivity, and that would give me a 0, 1, 2, 3, etc. But this example was thought out for something where you could even have things that are not connected. So for example, I could have here a torus, a cylinder, and a sphere, and they were not connected, but since they were occupying this space between 0 and 1, they would be considered a unit. So that's why I'm going with this way, because it allows to have meshes that are not connected considered as one unit. So what I'm going to do first is I'm going to get the point positions of the mesh, and I'm going to floor it. So in this case, actually I'm going to round it, not floor it. But so this mesh here goes slightly between minus 0.5 and 0.5. And by rounding it, I'm going to get 0. And so as I keep doing that to the array of meshes, I'm going to get 0, 1, 2, 3, 4. So basically I'm going to get the indices for the pieces. And so when I get that, I can then put them back in the origin, because I can use the indices as a value on the x-axis that I can subtract to them, and then everything comes back to the origin. So I had them displayed like this, so I could generate the indices, but then to transform them, I really have to put them back into the origin. Then the next thing I want to do, so in this case, this is on the x-axis. Here I'm going to distribute them on the y and z axis. And I could do this in this way. I'm going to do it like a box. So I'm just going to have some random values using these indices as the seed. And so I'm going to distribute them just basically a simple between -1 and 1, and between -1 and 1. I could do this in another way. So in this case, I'm gonna have something that looks like a square. But if I, for example, let's say that I've used the random values instead of z and y, I could do it like an angle, and so it would be 0 to 360, and then a length. So in this case, I would get something that looked like a circle, a filled circle. But I'm gonna go with this because it's much simpler in this case. And so this is another step. I want to distribute them on the y and z axis between -1 and 1. Then the next thing I want to do as well is to distribute them between 0 and 1 on the x-axis. Then after that, I want to move them. So I don't want them to be still. As you can see, they're moving here. Let me just check if the chat is yelling something at me. No, everything seems to be fine. The world is not falling apart. And so what I want to do, I want to move them. So even though I've distributed them, I want to have them moving as I have in my image. But I don't want them to go indefinitely, right? So at the moment they will be distributed between 0 and 1, and I don't want them to keep going forever. I want them to circle back. So when a piece goes, let's say, goes beyond 1, I want it to go back to 0. So that's why I have this little diagram in here. It's like you're playing Portal, right? The piece goes through this portal that is at 1, and it comes back in this portal that is at 0. And so it keeps coming back, circling back. And to do that, I'm going to use, now I'm going to use the rounding operation called floor. And so floor is an operation that basically just get us the integer part of a number. So let's say that I have 2.86. If I use floor on this, I'm basically gonna get 2. Now, if I subtract to my initial number its integer part, what I'm going to get? Well, I'm going to get the fractional part. And so this is what I'm going to do to the values that so I'm going to add to these values, but as they grow, I'm going to floor and subtract to the values. And so they're going to circle back between 0 and 1. So as they grow, and when they, 0 and 1. So they grow, and as they get closer to 1 and they pass it, they come back to 0. So it's going to look like a cycle like this. And this is what we can see here. And this operation is called modulo. In this case, it's a very simple one because it's modulo of 1. And so I don't have to do complicated things, but so it's just this. Then, things are distributed between 0 and 1, but this is not very interesting, right? Because, between 0 and 1 wouldn't give me this, would give me something that should just goes from here to here. So it's really small. So this is when I carry the curve. So I want to have the length of the curve. So I'm going to multiply whatever I got from this modulo operation by the length of my curve. So it's gonna end up looking like some distribution of pieces along a distance that is equal to the length of the curve. And then the final step will be to basically conform the pieces that are distributed. Let's say this curve is 20 units long. So I'm going to have pieces that go between 0 and 20. By multiplying these values that come from the modulo by the length, I'm going to get pieces that go between 0 and 20. And then, depending on the application I'm using, I'm going to use a curve deform, and that curve deform will basically map the pieces from this, these pose on the x-axis along the curve. So a lot of the magic, so to say, it's actually going to happen. It's going to be very boring, and it's going to happen in line on the x-axis. Then everything that was done on the x-axis is put along the curve. So that's it. Let me just check the chat to see if there's any question. Looks silent, so I guess it's a good sign. So let me jump to exercise, Softimage, and so here I have the pieces, and so here I have a nice tree, and just basically get to the position, set the position, basic stuff. And here I have also the curve, where I have the curve length that I'm going to use later, like I've shown in here. So first thing that I want to do, let's go through the picture here. First thing I want to do is to generate the indices. And so to do that, I'm just going to pass around on the x coordinate. And so vector to scalar and round. And with this, I got the indices of each piece. Now, I want to put them all into the origin, as I have in here. And so basically I just subtract this. I mount this on a vector. So scalar to 3D vector, put it on the x-axis and subtract. And now everything goes to the origin. Great, so I got my pieces ready to be transformed. Now I want to distribute them on the y and on the z axis between -1 and 1. And so where I'm going to get the integers, the seed for the random, I'm going to get them from here. So let me call here random value, and let me put the range of the random value. Let me activate here the mean value. And so the mean value, it's what's the reference value. So in this case, I want it to be 0, and the variance, I want it to be 1. So it goes between -1 and 1. Right, and so I'm gonna connect this here into the ID, and I'm going to put this on the y-axis. Now I'm gonna put another one, but I'm going to change the seed. So it's very important with these pseudo random nodes to have some variation. So because they are consistent, if I give let's say 3, let's say it gives me a value of 0.2, and if I give it the value 3 again, it's going to give me again 0.2. And so this is quite nice, because it means that, you know, whenever you turn on the scene again, you're not going to have different results. When you're trying to map random values to parameters, if you keep using the same values, you're going to get values that match. So for example, let's say that I make a piece, let's say purple, and I also make it go fast. And if I use the same random values to get to those parameters, basically it means that all the pieces that are purple are going to be fast. And maybe I don't want that. So I have to have an offset for the seed. In this case, here in Softimage, I can just change that. So I can just come here and type something else, and that will give me a different seed range. This way, it means that the random values that are generated from these indices are not going to match. That's what I want. So I'm going to put this here on the z-axis, and let's see. I'm going to multiply by matrix, and I'm going to need to define a matrix here. So 4 by 4, put this here, then call SRT to matrix and put this here. Right, so now you can see the distribution like I have in the picture. So they are distributed on the Y and the Z axis. And to show what I was talking about, I don't know if it's going to be very obvious here, but let me put 1, 2, 3 in here, the same seed. So you see, since they have the seed is the same, it's going to give me the same value for the y-axis and for the z-axis. And so in this case, everything goes on a line. So even though it's random, you know, it's going to look very too consistent. And so that's why you want to use different seed ranges for different for the parameters that you want not to match. Great, so I got this sorted here. Actually, I think I'm gonna have 2 of these because later I want to transform. Yeah, so I want to put this here, put this here, right. Okay, so now I want to distribute them on the x-axis, so from 0 to 1. So basically just gonna do the same thing. And let me put again the integers into a random value and change the seed so it doesn't match. And then on a scalar to 3D vector on the x-axis this time. And so let me put this here on the translation. You're probably wondering why am I not putting this here directly. And so the reason for that is that I want to transform this part here afterwards. And so that's why I already have here the transformation inputs. Okay, now in this case, I don't want it to be between -1 and 1. So I'm going to change the mean value to 0.5 and the variance to 0.5 as well. So it goes above 0.5 by this value and below 0.5 by this value. So between 0 and 1. Okay, so now I have them, you know, with a value between 0 and 1. And now I want to start to add to this value, right? So I'm gonna put here add, and let's say, yeah, I want to make them move. I want them to move, but I want them to cycle back. Like I said in here, I want to create this portal system where they, you know, they go back to the beginning. And so in here, there's a modulo in Softimage in Ice, but this modulo, so each, depending on, you know, what's the rounding operation that is used on the modulo, it's going to behave differently. And unfortunately, I don't usually like much how the Ice modulo works, because it's going to do something for, you know, for let's say 0. So it's going to do this on the positive values, but it's going to do this on the negative values. And I kind of understand why it does that, because, you know, maybe there's, you know, some symmetry here, and that can be useful. But usually I want some consistency, and I would prefer it to do something like this, to keep going doing what it was doing. So since I said it was, you know, it was very easy to do this modulo because it's modulo of 1, I'm just going to use the floor and subtract the integer part to my number, so I get the fractional part. And so let's do that. Okay. So floor. and then subtract the integer to the number. And let me put a pass-through. And so now, as I increase this, you can see that the pieces, they try to go forward, but they are always reset back to 0. All right, so this is what I want. Okay, I'm going to put a pass-through here as well, because this is going to be a very useful, the output from this, it's going to be very useful. Why? Well, because it's always going to be the fall off along the curve, even after I scale this so it matches the curve length. I can use this parameter that goes between 0 and 1 to distribute transformations. Maybe I want to transform the pieces from the start to the end of the curve, and so the output of the modulo is going to be very useful for that. But so now I want to multiply it by the length of the curve, which I have in here with this curve length, and I'm just going to multiply. And so by doing this and this, I can just put it there. And so now I have something that starts to look a bit more like the final thing. Oh, I forgot. In here we have these random values. They are time varying, so we have to turn that off. Otherwise, every frame is going to have a different value. Right. So now, as I scrub the timeline, nothing changes as it should. I can put time here, current time, and let's see if I scrub the timeline. Yeah, that looks nice, right? So have the pieces being reset back to 0 when they go to the end of the length of the curve. And I could actually just now apply curve deform in here. So deform by curve and choose the x-axis. And there we go. So now I have that effect that was linear happening along the curve. Maybe it's curve could be bigger, so I'm just gonna scale this. Right. Now, overall, we could say, oh, okay, that's done. Off I go. But well, that's this part I was talking about, the modulo. It's now, you know, where it gets I think fun, because now I can distribute transformations along the curve by using the value that comes out of the modulo as the u value of the curve. And so let's see, for example, here I'm going to put a linear interpolate, and let's say that I'm going to axis angle to rotation. Right, and I'm going to put, so the axis that I want to rotate about, if I turn off here the curve deform, I want to rotate, let's say I want to rotate them to, I want to have them roll, so I want to rotate them around the x-axis. So it's what is in here, and I want the angle to go from, let's say, from 0 to 360, just to see how that looks. And so that modulo output I'm going to put on the blend. And so here I have two places where I can put the rotation. Let's look into that. So I have this one and I have this one. So why did I go with two? Well, because this one is going to transform the position of the piece relative to the axis. So I have the, let's say I have the x-axis and I have a piece in here. And so when I rotate here, what I'm rotating is the position of the piece around the x-axis. And when I rotate in here, what I'm rotating is the position of the piece around itself. Right? So two things. This is going to make like the piece is swirling around the curve. This one is gonna look like the piece is swirling around itself. And so we can check that by putting this here. And as I advance the timeline, yeah, it's very subtle. Let me put it on the piece rotation as well. So now you can see some pieces turn. Yeah, I think it's still very subtle. Maybe there's not enough time for them to. Let me try to slow this down a little bit. Let me put, let's say, 0.2 just to see if it's enough. Okay, maybe now it's easier to see, right? They're spiraling along the x-axis. Right, so now if I if I activate the curve form back again, you can see that it's like they're spiraling about the curve. And I can increase, so for example here, instead of 360 I could put 1080, and so looks like there's a lot of twisting going on, right? And so maybe the other thing that I think it would be nice to change is the scale. Maybe on the tips I want the pieces to be smaller but also be closer to the curve, constrain more to the curve, and at the end of the curve have the same thing. And so again I can use this modulo output since it relates to the curve U, and so F curve, and I'm going to draw here a profile that goes something like this. So at 0.1 or 0.2 have the value of 1, and at 0.8 have the value of 1 as well, right? So this will make that the scale comes down to 0 at the start and also at the end. And so I'm gonna bring another linear interpolate, and I'm gonna put this in here and put this on the scaling. So I'm gonna put 1, 1, 1 in here, and you can see right away that the tips got scaled down, but the pieces themselves, so the path was scaled down, but the pieces themselves are still big. So I need to put this this transition also here in the pieces, and so now you can see that they are also scaled down, and so now I get this sort of thing going. Now maybe one last thing that I could do that I was actually intended, it was intended to be done from the start, but I kind of forgot to change the speed, have them have a different speed. So some of them, as you can see here, the speed is not constant, right? So you can see that there are some pieces that go faster, and so let's do that. I'm gonna have another random value, and so this time let's say I'm gonna put this here, and so this is nice, and I'm just going to do a rescale between, so I'm gonna change the seed so it's something different, well, too big, and I'm gonna rescale this from 0.5 to 2. So with this I'm going to multiply the speed that at the rate they go. So for example, if I put this here, now you'll notice that some pieces go faster than the others. Let me put this even faster, let's say 3 or 4, so you can really grasp that. Now maybe I should put the speed here back up, so let me put this to 1 and put this to 2, 0.5 to 2 actually. Yeah, I wish there was a way to show them a little bit slower actually. Let's see. Yeah, I think you can see that some go faster than others. Maybe it's not too obvious. I don't know. Let me maybe check the chat to see if people. Let me put this really high just for now. Let's say 0.1 to 10. So that doesn't get, yeah. So you can see some of these. This one here, it's almost dead on tracks, right? And there's other ones going really fast by them. So that's it. So I'm gonna put this back into something a bit more reasonable. So let's say 0.5, and this to go between 0.5 and 2. Now, before I talked about using a different seed for different random attributes, but let's say that I want to have the scale of the pieces to be relative to their speed. So what I'm defining here is the speed of the offset. And so let me put this back. Let's say that I want to reduce this to affect their size so that the slower pieces are a bit more chubby and the faster pieces are slim. And so I can do that by just putting here an invert and scalar to 3D vector. Right, so if something, let's say, if something is 0.5 in speed, it means that it's slow. And so I want it to be also short on the x-axis, but I want it to be fat on the y and z-axis. So if I come here and I multiply the pieces size around themselves, let's say I multiply this here. Multiply. Nope, not this one. The regular one. Right. Whoa, that was too much. Let's see, did I connect the right thing? Nope, I connected the random value. I should have connected the rescale output that goes between 0.5 and 2. So that's what I did wrong there. Right, so now you can see that I have some pieces that are, you know, shorter and fatter, and others that are longer and more slim than the others. And so it goes like that. I can scale them, all of them, a little bit, right? I can just put here a multiply by scalar, and I can scale. If I think they are not occupying enough space, I can always do this, right? So let's say that I want them to be sort of like this, right? Let's say 2 times, it's enough. Great. So this is it. Let me just check the chat to see if there's some question or something that it's going on. If the house is on fire, something like that. I'm waiting for Blender. Of course you are. Okay. I guess I'm gonna move on to LightWave. Blender will be the last one, so maybe I should have mentioned that in the beginning. So the first portion, yeah, I definitely forgot to mention what I was going to do. So the first portion is what I've already done here. So it's presenting what's the goal. Then Softimage. Then LightWave. Then Houdini. And last Blender. And this one is it's probably I'm gonna fail a lot in Blender, I think, but let's check. Okay, great. Let's move on then to LightWave. So I'm gonna leave this here. Or actually, I'm gonna call it done. Right, and so let's move on to LightWave. Now in LightWave, it's a bit tricky because I don't have curves in here, so I'm using a curve deformer. Well, in layout, so I'm using a curve deformer. It's called Spline Deformer by Denis Pontonier, and it's a node. And so here it allows me to select a bunch of items that are to be used as a curve. And so these are the items we see here. And so at frame 0, this is like capture in Houdini. So at frame 0, they are in the rest position. And then here at frame 1, I pose them like the curve I want to have. The other drawback is that I cannot carry this curve. So I cannot, unlike what I've done here in Softimage, where I scaled the distribution of the pieces using the curve length. Well, I cannot do that in here. So it's basically going to fit them, oh, okay, I think this looks fine, I'm done. So that's a drawback. And the other thing is this works best on the z-axis. So even though I have the pieces distributed on the x-axis as before, at the end of the evaluation, I'm basically going to rotate them by -90 degrees on the y-axis, so that they look like they are on the z-axis. But well, that be said, yeah, there's some quirks here in LightWave, but let's get on with this. So first step, generate the integers, the indices. And so this is going to be done here with a round node. So split vector. Actually, yeah, no, never mind. So round node. So this part is like, if you already grasped what I've done in Softimage, from this point on is going to be a bit of a repetition. So I'm going to round the values, and I'm going to put this on a subtract scaled, and the subtract scale I want it to be on the x-axis. And so actually the second one, so I want to subtract to my initial piece's position a vector on that is equal to the x-axis scaled by their index, sorry. And so if I put this here, everything should be going to the origin, but it's not because I forgot to connect this here. And yeah, mistakes were made. Okay, the output is here. Sorry, I even renamed this node as out, so I wouldn't miss it. But yeah. This subtract at exit is because LightWave's displacement is basically an offset, so it's going to add. And so if I'm working with the initial positions, I have to subtract them to generate a delta. So that's why this is in here. Anyways, okay. So I got the pieces on the origin, just like in here. Let me now distribute them between -1 and 1 on both y and z axis. And so to do that, I'm going to use the index that comes from here and random scalar. So I'm going to have 2 of those. And I cannot have a seed offset here. So what I'm going to do is I'm going to do the seed offset myself. So this first one is just going to take the seed value in there. And this second one, I'm going to offset it by some random big number so that the seed range is different and the properties don't match. All right, so I'm going to do make vector, and I'm going to put this on the y, this on the z, and let's make a transformation sequence. Wow, the music, it's getting really uppity. Let me check this. Yeah, it's a bit more quiet. Okay, so let me do a transformation sequence. Add, vector add, rotate, and multiply. So actually the sequence is the other way around. So it's multiply, and then rotate, and then add. So scaling, rotation, and translation. So here in LightWave we don't have yet a node to transform points with those three directly, but I think we're gonna have, it's coming soon, I hope, but at the moment I have to do this myself. So just turn on world coordinates here, and so I'm gonna put this here on the multiply, put 1 1 1, otherwise it's gonna multiply everything by 0. And so let's see, I want to transform this one. Sorry, let's see the vector, and what I want to transform, it's this. So I want to add to that, right? So as I put this here, you can see the distribution, and you'll notice that I forgot to put this between -1 and 1. Right, so now the pieces are distributed like in here between -1 and 1. Now I want to distribute them on the x-axis, and so this is going to be something that I want to transform later. So I'm going to replicate this, and I'm gonna put this here, and I'm gonna put this here. Right. So in this case, I'm going to put the x-axis offset in here, and so let me use another random scalar node with an offset, and I want the range to be between 0 and 1. And I'm just gonna put this here, have a different seed range, and make a vector on the x-axis. Great, so now I have the distribution between 0 and 1 on the x-axis. Now I want to add to this distribution, right? I want to create the portal thing. And so I'm going to add, scalar add, and I can add time. So if I come here and I put time, let's see what happens. Right, that gets going. Let me put this back to 1 just to be safe and not change the keys. So that looks a bit slow, to be honest, but if I think it's too slow, I can change that later. Right, so now I want to do the modulo part, so that I have my portal and the pieces going back and forth. And so I just put, in this case here, I like the way the modulo node works in LightWave, so I can just put that in here, put 1. So this is my clock size, and so that's fine by me. So now as I scrub the timeline, you can see that the pieces go back and forth. Right, so this is going to be the value that I'm going to use as my curve U, so I can distribute all those transformations, the rotation and the scaling. And so what I'm going to do now is I'm going to scale this by what I think is the length of the curve, so I can have something that fits the length of the curve better. And so let's say I'm gonna put I think maybe 20 might, no, say 30. Okay, so I'm gonna come in here and activate here the spline deform. So I'm gonna put here, and so now you can see the pieces are deformed along this spline path. So I have something like this. Now, yeah, 30 is not enough. Let me go with 40. Now, okay, that looks much more fit. Now let's do the same thing that I did for speed. So I don't want them to be offset at the same speed. So in this case, I'm going to multiply time, and I'm going to multiply time by some random value. So again, another seed offset, and let me put here another random big number, and so between 0.5 and 2, like I did before. So let's check that. And so I get some random speed. Well, probably doesn't show too much. Let me put 0.1 and 10. So yeah, you can see, for example, again, these pieces here are going quite slowly, while others are going quite fast. In Houdini, it's actually going to be a bit easier to spot, because now that the pieces are they all look the same, right? So it's a bit harder to notice that. Okay, so let me also use the speed to affect their scale. So I want the slower ones to be a little bit more chubby. So divide, scalar divide, and I'm gonna divide this by, I'm gonna invert this. In this case, I don't have here an invert node. So basically I do the multiplicative invert by dividing these values by 1, or 1 by these values actually. And so make vector, the music got a bit too uppity again. So I'm gonna put let's say if something is 0.5, I want it to be short and fat, and so that's where these two, the Y and the Z values, come into play. And so if I put this on the multiply here, now you'll notice that the slower pieces, let me pull this down, notice that this piece is shorter, and these pieces here are longer. And so as I move the timeline, you can see that those go faster than the short one. Okay, now the scaling fall off, or I could do the rotation as well, right? So let's see, I have here the modulo, and I want to remap this from 0 to 1 to be a rotation on the bank. So actually no, on the pitch. And so make vector and put this in here, angle. I'm guessing that people that are not like LightWave people are tearing their eyes even more than people that are LightWave and that are also tearing their eyes. So I'm gonna put this on rotate here, and I'll rotate here as well. So it's going to not just rotate their path, but also the piece itself. And so as I scrub the timeline, I think I have to slow this down. I think it's really hard to see anything at this speed. Okay, so let's put, let's say 0.2. Yeah, okay, this is a bit more friendly. I can see things now. Great. Okay, I'm gonna scale this a little bit, because let me put here scale, so I can see what's going on actually. And 200. Right, so now these are a bit more interesting. Great. Now the only thing that I'm missing here to make something like what I've done in Softimage is to just basically scale the tips. So not just the piece, but also their position relative to the axis. And so for that, I'm going to go back to the modulo, and I'm going to call curve filter. Nope, curve gradient. Yeah, could be. Well, actually, I'm going to use a gradient curve. Right, so I'm going to do the same thing that I've done in Softimage. So I'm going to put this position at 0. Another one at 0 at the position 1. And then at position 0.2, one with value of 0.2. And at position 0.8, another one with value of 1. Right, so something like this. Now, this is going to be used to interpolate between 0 and 1. So here we use the mixer. I'm going to put this on the alpha. Right, and so now I want to put this on scale. So let me put this here to see how it looks. And it's doing what it's supposed to do. So as you can see, the pieces in the beginning of the curve are closer to the path. Now I want to scale them as well, not just the path. And so what I'm going to do is I'm going to multiply this here with that with this mixer as well. So like so, okay. And so now this looks like what I've done in Softimage. I'm sorry for taking you guys down this path. For some of you, maybe it's the first time you see LightWave. And let me just color this. So I'm just going to put an offset here. And put this between 0 and 1 and do a store material, put here and say rend, and then come here to, actually let me save this, save scene as, let's call this one done, right, and save all, just in case. And so rend, turn on VPR, go to the surface editor, and let's say get material. So rend, and now with the rend you can see that I got some colors just like I had in here. And so this actually is a good one to show what I was talking about, the modulo output. Let me come here back to the displacement node editor and just do another one, but for the modulo. So store material and put this here and call it curve view, for example. And then go back to the surface editor, get material, and let's say curve U. So this is just to show the difference between one and the other. So this one gives you a gradient along, so the modulo is going to give me a gradient along the path. So as the pieces move, their gradient value or their U value also changes. While this one just shows that I can have the rounding that I did in here. This rounding gives me access to be able to manipulate each piece. And so this here is just, here is just made visual. So the pieces all they keep their color. So this yellow green piece always gets that color. Right, so I'm done with LightWave, and let's see what the chat is saying. What names are they calling me? And right, okay. Hear that last. Of course. I love how there is no Maya or Max. Yes, I love that as well. Great. Think I can move on to Houdini. Let me just mute the microphone for one moment and take a sip of water before I do that. All right, that's much better. Now let's go to Houdini. So here I have the same thing. So again, if you already saw the effect 2 times, you know, it's like repetition makes it perfect. So I have the pieces, and let's go outside. So I have the OBJ that I use to put the pieces in all applications. And I have the curve in here. You can see it here. And well, let me actually hide all objects. So the curve is being resampled. So there's no magic way to get the curve length. What I'm doing is I'm using a measure node. But for the measure node to work best, I have to resample the curve so that instead of something like, let's say, let me come in here, something like this, where I have only these few points, I get something with more points, you know, something like this. And so the measure for the measure node to work best, it's best to have something like this. You can see how it changes as I here. Basically, I use this measure node to set a parameter called an attribute called curve len, and so that's I have to choose the perimeter for that to work. But yeah, this basically gives me the length of a curve, so that's nice. But you notice that here I have 15, and if I don't go through the resample, well, I'm gonna get 18. So that's not as accurate, because it's going to look at the segments of the curve, like, you know, something like this. So this is going to, you know, have a bigger length than this. Anyways, let's move on. So the effect is going to be set up in an attribute fob. So I have as inputs the pieces and also the curve length. And what I'm going to use to do the curve deform, well, I was a bit, you know, surprised when I noticed that Houdini doesn't have a curve deformer. So I've done one, and I've put it on Orbolt. So when you open up the scene, because I'm going to share the scene files. When you open the scene, please go to Orbolt and download this one. So I have done 2. This one is really simple, and I've done another one with more parameters. But for what I'm doing here, this one is just fine. So it just has 2 options. What's the axis that you want, and if you want to fit the mesh on the curve. So if I click here, fit on curve, and notice that all the pieces are fit between the start and the end of the curve. But yeah, make sure that you get it, or you can do your own. That's the cool thing about, you know, Houdini. Just, I want to do a curve deformer. Let's go. Woo! Anyways, let's go to the effect. So inside here, this attribute fob that is set to run over points. I got the importation of the curve length in here, so I can have access to that. And I'm going to use here a subnet thing that I've done to have a random value with a seed and also a seed offset. Right, so here inside you can see that I just basically use a random node, but I add some offset to the values, just like I did in LightWave just now. And so this way I can, you know, I can duplicate this. It's much faster to just duplicate this than you know, copying this around. Okay, so let's get going. Too much talking, not much doing. And so let's start with what I've done for the other ones, which is to find the indices. Right, and so to find the indices, I'm going to split the positions, and so I'm going to do that with vector to float. Whoops, not this one. Vector to float. There we go. And I'm going to use the round, and so this is going to give me the rounded value for the point positions. And so with this, I can put the pieces back into the origin by subtracting their current position by the index value. And so I'm going to do a float to vector. And I'm going to subtract that to my initial position. And let's see. Subtract this. What do I get? Everything at the origin. Yay, that's where I want it. Okay, so I'm gonna get something like this. Like it's the first time you see this, right? It's very exciting. But yeah, so this is my what I'm going to work with, the pieces at the origin, and so I'm going to transform them. And so for that, I can have here the transform matrix, where basically I'm gonna do this 2 times, just like I've done in XSI and also in LightWave, where I'm going to transform the pieces themselves, but also the position that I give to them. So I'm gonna put this one here on the translation input. Now let's take care of the distribution, right? So I need to generate some random values. So I distribute the pieces on the 3 axes. And so this is where this little thing comes in. I'm going to access the seed here with the result of the round node. And I'm going to do this 3 times, 1 for each axis. And for the x-axis, well, actually I'm going to use the x-axis one, this one in the bottom. I'm going to put this up, and so this is for the y and the z axis. And so I want the distribution to be between -1 and 1. And on the second one, I want to have a seed offset. And so now if I do float to vector, and I put this on the y and on the z, and I put this here on the position, you get the distribution. If I didn't put any seed offset in the second one, again, I would have everything distributed along a line, which is quite boring. So let me offset the seed. That looks better. Now I'm going to do that for the position along the x-axis as well. So I want these to be between 0 and 1, and I also want to add it a seed offset. Float to vector. Delete these links and put this here and put this into the translation. Right, so that looks like something that we've seen before. Now I want to add to this position and do the portal thing, the carousel. Right, so I'm going to add, and to be honest, I haven't grasped yet the thing about being inside an attribute VOP in time. So what I've done is I'm just gonna call this my time, right? And let me come here outside, and on my time just put at time. So this will give me time inside the attribute VOP. So some Houdini expert is like, this is not how it's supposed to be done, and I'm very sorry for that. But yeah, so now with this I can get this going, and I just need the modulo. So modulo, and now I have the pieces being cycled back. Let me just go ahead on the music. Yeah, this looks nice. Go back to Houdini. So now I have the pieces doing the carousel with the modulo, right? They're going, when they get over 1, they go back to 0. And so let me put this here. And so I want to also change the speed, the rate at which time is added onto them. And so I'm going to put here a multiply. Right. And so on the multiply, I'm also going to have a random value. So I'm just going to duplicate this subnet, and I'm going to change the seed offset, and I'm going to put from 0.5 to 2, and I'm going to put this here. Right, so now there's some that are faster than others. This is becoming quite hard to visualize with everything cramped between 0 and 1. So what I'm going to do is I'm going to right away multiply this here by the curve length, so that we can see better what we're dealing with. Okay, so the curve length is here. So in the curve length, in this one, I had to put the attribute name, and I also had to put a constant node with 0, otherwise it wouldn't work properly. So I have to tell it that I want to inspect the attribute curve length on the primitive number 0. Right. So I'm gonna come here, just put this, and now the pieces are distributed between 0 and the value that is equal to the curve length. And so now when I scrub the timeline, we get this. Now this is probably a little bit too fast, right? So maybe again going to multiply time by some value. So I can just put here constant, and let's say maybe 0.5 is fair, so we can see things. Yeah, I think this is fair. Okay. Another thing that I can maybe do right away, let's see if is to color the pieces. And so just gonna put here a random node, and I'm gonna change this from 1D float to 1D output to 1D float to 3D vector. And so if I just plug this onto CD, I think this should change. Yeah, nice. So now I have the pieces being colored like that, right? That's great. I'm just going to add an offset to the first one because this one has no offset, and so I'm just, so that things don't match, I'm going to add the offset to this one. Great. So let's carry on. So maybe I can put this already on the curve, so I can look at it. Okay, so it looks like this on the curve. Let me scrub the timeline. Yep, and I guess I want the curve to be a little bit bigger, so I'm gonna come here and then put a transform on the output of the curve. And let's say I'm going to scale this like so. Yeah, this seems a bit more fair. Right, so back into the attribute file. I have the distribution and the cycling on the curve's length done. Now I want to change some attributes, scaling and rotation. So for that, I'm going to use the output of the curve U. Sorry, the output of the modulo that relates to the curve U. And so let's take care of the scaling. So wow, music again, going too happy. And so let's call in a ramp parameter and change that from spline, from RGB to spline ramp, so it's a float. Right, so now one thing about the ramp is that I have to go outside to edit it. It's a bit annoying, but you know, it's doable. So I go here outside and I have the UI for my ramp. And so what I want is put a key at 0.2, position 0.2, right, and another one at 0.8. And so these two, I want them to be 1 and 1, and the first and last one, I want them to be 0. So it does something like this, as we've seen before, so that the position, the scaling is 0 in the beginning, then goes to 1, and then goes back to 0 at the end. And so maybe I would want this to be sort of like, you know, smooth. So let's see what the monotone cubic does. Well, I like that. That looks fair. So monotone cubic for all the keys. Right, and so now let's go back inside into the attribute VOP. And so I'm going to use this on a mix. Right, and the mix is suppose the signature, I'm going to change it to 3D vector. And so if I put the ramp on the bias, and I put this both on the piece transform and on the path of the piece transform, let's see what happens. Great, so now I have the same thing that I saw before, where not only the pieces are scaled down, but their distance to the axis is scaled down. Right, now I think I'm only missing the rotation and also the speed of the piece to control how chubby or how slim the pieces are. So okay, let's use the same ramp to distribute rotation. And so I can do that. Again, I think the music is a bit too loud. I never know. Let me check the chat just to see what goes on. Yeah, it's all good. Voice, my soul. Okay, cool. Seems to be working fine. Okay, and so I'm going to have another mix here. And so this time it goes between 0. So I want to rotate on the x-axis, right? So even though this is already wrapped on a curve, when I think about what I want to do to the pieces, I have to think about them in rest, like this. This is when I think about the transformations that I'm doing now, I have to think about them in this state. Right, so in this case, I want to rotate them around the x-axis. And so let's say that it goes from 0. I never know if this is using radians or degrees. I never remembered from the top of my head. So I'm just going to put, let's say, 12. I think it's fine. It's two rotations. And so let me put this into rot here and rot here. Right, let's see what the I don't see them rotating too much. So maybe this input is using degrees and not radians. So I'm gonna put 1080. Right, and I think this will show something. Yeah, they're also a bit too small, so I think I'm gonna scale them a little bit. And so to scale them, I come here to the last transform, and here on the scale, I'm gonna multiply that. So multiply, I'm gonna put the scale in here, add a constant, and let's say I'm gonna put 2. So yeah, the pieces are a bit thicker now. I'm not seeing the rotation much, so to be honest, let's see, am I doing something wrong? So 1000 rotation. I'm not feeling them rotate that much. Oh, I'm an idiot. I've put the ramp, so of course they're just rotating from here to the ends. So I shouldn't be using the ramp for the rotation if I want the rotation to be along the whole curve, right? So my bad. So I'm gonna put this in here, and this is what I was looking for. Okay, let me just check if this is radians or degrees. So I'm just gonna put, let's say, 12, and yeah, I think it's degrees. Not really sure, but yeah, I think it's degrees. So 1080, and that should do. Great, so last thing that I need to do is to change their scale according to their speed. So the speed is being defined here in this multiply with this random value. And so I'm going to invert, or let's say divide, and constant, put 1 in here and put this in here. So if I get 0.5, I want the piece to be short on the x-axis, but fatter on the y and z-axis. Right, so this should work. Let me put this here. And so now I have, you can see, for example, this red piece is probably slower. No, you can, yeah, this one here, it's slower. And for example, this green one, it's faster, so it gets thinner. Right. So this is it. I think I think I didn't forget anything. But well, of course, the fun part in these, right, is to edit things that are before them. So for example, here I could go onto the curve and edit the curve, and you know, just have fun with the path and see that change. So these are of course very fun. I use this setup. Actually, I was looking into this setup when I was doing a system where I would have to have some like cars going, some random cars. They didn't have to, you know, they could be cars, but you know, in this case it was a bit of abstract, so it's just some boxes. And so I use this as a flow of cars on a road. And so it was really nice to basically get one done and then just apply this to a lot of paths. So yeah, let me just check the chat to see if there's some question. And if not, I'm going to finally go to Blender, and let's check that out. Okay, not much to go on about. Let me check the launch. Okay, thanks. Right, I think I'm gonna carry on then. Someone is writing something. Message, of course. It's gonna tell me now. Blender is now. Yes, finally. All this time I was waiting for Blender. Well, let's move on to that. I'm just going to save this scene so I can share with people. And so just put done. And let's move on to Blender. All right, so here in Blender, our last stop. So in Blender, we have animation nodes. So it's something that you have to install. So if I come here to add-ons, right, so animation nodes is something that you have to install to have access to a node interface like this. So take care of that before you try to do this, because at the moment, I don't know in the future, but at the moment, Blender doesn't come with it by default. So there are some templates. Let me just duplicate the file. So duplicate objects, right. Just gonna hide this one for a moment. And so what I have here already, so let me, maybe I should do this from the start, maybe, I don't know. But so you have to come here, and if you don't have one, you have to click in this plus sign, and that will create a new node tree where you can start to do things. So let's say if I delete this, no, it's not deleting it. Anyways, if you don't have anything in here, you have to create a new one by pressing plus. Right, so I was looking in how to do this in Blender, and so the quickest way, so there's a looping mechanism here, and so there's some templates, and one of them was really useful for this. So there's the random vertices offset template, and if I come in here and I just put, let's say, default 2 in the input mesh and default 2 in the output mesh, you're just gonna see this, get random distortion. So this is not what I want, but the setup, what is put in here, the looping on the points that this template shows, that I want, right? So what I'm going to do is I'm going to delete this, and you notice that the mesh now looks like this. So that's why I duplicated, so I can just delete and go back to this one. And so I'm going to bring up the template again. So random vertices offset. And basically what I want is this. So I don't want this random vector to be added onto my positions. So I'm going to delete this. And now I think it's safe to add my object in the input and also on the output. So I'm going to put here default, and here I'm going to put default. So now what's happening here, and I don't see it, is there's a looping that goes on the positions. And so basically now I can start and start working and do the thing that I did before. So first, in this case, I want to split the vector positions into float. So let's see if yeah, the blender shortcuts, they're gonna betray me at some point. So combine, decompose, no, vector, let's see, combine vector. This is something that I want after, but not what I need now. So let's see, Control A, what is it called? Vector, separate vector. There we go. That's what I wanted, of course. Right, and so now I want round number, and can put this in here. And so by doing this, what I'm doing is this first part here, where I'm getting the indices of each piece, because the pieces go on intervals of, in this case it's -0.5 to 0.5, then from 0.5 to 1.5, and this all gets when I do round, they are all put into integer values. Right, so I got my indices. What I want to do next is to put subtract to the mesh the indices so that they all go into the origin. And so subtract vectors, right? And I'm going to put this here on the x-axis, and I'm going to put this here. So now all the pieces are, let me select this. So now all the pieces are at the origin, just like I wanted. Great. Now let me do the rest. Yeah, sometimes I don't know. Yeah, I have to use the G key. So you have to use the G key to move them here in the node editor. It's something that always gets me. Okay. Now I have, let me create some space in here. Right. Okay, so now I can move them, and so the way I'm going to move them is I'm going to multiply. The way I'm going to transform is to, I think it's, let's see if it's transform or multiply by a matrix. Transform vector. Yes. So I'm going to transform them with a matrix, and so to do something here, I'm going to have to compose a matrix. And so the matrix composition comes with translation, rotation, and scale. Right. Now I'm going to do another one of these, as you remember. So I'm going to put this here. I'm going to put this here as well. Actually, I'm putting this in all the wrong order. So this should be here, and this should be here, and this should be here. Great. Now I want another one of these, and so I want to transform the translation. And so I'm gonna need another matrix for that. Right, so let's go to the distribution of the pieces on the Y and on the Z axis. And for that, I'm going to use get a random value using the integer. So let me select this, and oh boy, let's see. Help me, Blender. Okay, here we go. And so random number. Here we go. Right, so as the seed, I'm going to use the rounded value here. So I'm going to put this here. It's going to be converted into an integer automatically. And so I want the distribution of this to be between -1 and 1. And I want another one of this. And so copy, paste, put it in here and change the seed. So in Blender, I actually don't need to have a seed offset scheme. I just change the node seed directly, just like I did in Softimage. So that's quite nice. And now I'm going to I have the habit of pressing tab on Houdini and Softimage, but whenever I press it in here, you know, it puts, like, it zooms out and focus on everything. So that's tricking me. Okay, so I want to compose a vector, or let's say vector, combined vector, and I want to put this on the Y and on the Z axis. I actually quite like the nodes in Houdini. It's just that I'm not very used to use them, so they always trick me, or I trick myself, something like that. So I'm going to put this in here. Wow, that's doing something. What's going on? So position is being split into a rounded value. I guess I missed something here. I'm doing something wrong. Everything has the same. First, I don't know why this is dancing, because when I tried this before, it wasn't dancing. Are the random nodes also animated? Let's see. Apparently not. What's going on? Let's see if Maciej has something to say on the chat. I've applied this motion effect to one curve. Let's say more curve. Let's say 5. Yeah, you probably could loop in Houdini. You could probably loop and merge the meshes as you go. There's probably lots of ways, because since you have access to integers, you could also use these integers to distribute them among several curves. So let's say I have 0, 1, 2, 3, 4, 5, etc. Let's say that you want to distribute the first 4 to, let's say, this to curve 0, this to curve 1, this to curve 2, this to curve 4. And you can do that, keep doing that in blocks. So this is another way. So there's many ways to go about that. Ludwig, honestly, I don't know why it dance. By the way, you can change the shortcuts. I know, dude. I tried this the other day. It was working fine. Like, I really don't know why is it dancing, because it's the first time I see this happening, and it's quite frustrating, because now what I'm supposed to do. I have no clue. I really have no clue how to fix this. I was afraid of Blender, but not because of this. So it's a bit annoying that I don't grasp it. Maybe I could, well, I could try to do this from the start, but I guess it's really annoying for you guys. Whoa, yeah. Maybe it's something in the node output, something that, of course, I'm not used to it, so I don't know. So the first time I've done this, it was, you know, it's pretty simple. Okay, we're gonna do something. We're gonna open up one that I've done that is not dancing, because at least, you know, at least I can explain what I've done, and I don't just say, well, I can't do anything, and I close the thing. So this one I've done already, so I just basically going to explain what I've done here. I'm sorry, I don't know why the pieces are dancing. I'm sure it's going to be something simple afterwards, but at the moment I have really no clue. So this is the looping, and so it goes through the points. Let's see again. So I separate it, I round it so that I get the pieces, the indices of the pieces, and then I subtract that. So here I have the subtract, so I put the pieces back into the origin, and then I transform the pieces like I was trying to do here, where I have this transform vector with this compose matrix and another transform vector with another compose matrix. Right, so for the first one, what I'm going to have is the distribution along the Y and the Z axis. And so this part over here, and then transform on the position of that. So here on the translation, I'm going to have the distribution on the x-axis. So that's why you can see here this float is going into the x-axis, and this comes from a random number to which I add and I also multiply. So this defines the offset that we can see when the pieces move, and this defines the multiply, defines the speed by which they are offset. Now after those offsets are done, I have a modulo, right, like I had before. So here I have this modulo, and so this modulo, it's going to give me a value between 0 and 1 that relates to the curve u, and then that is multiplied by the curve length. The curve length here, I have access to it. Let's see, whoa, this navigation's a bit wild. The curve length, I have access to it with this node called get spline length. And so do not use this node inside the loop, because when I tried to do this and I plugged it directly in here, it just basically killed Blender in a way. So the best way, so since this is a static value that's not going to change per loop, just put it in here in the loop inputs. And so here I just used the strength. It was a parameter that was there before, and this way it's accessible here through the loop node. So I just have the strength come here and multiply. Sorry, sometimes this jumps really fast. Okay, so I just multiply that value, which is the curve length, by, wow, jumped again, by what comes out of modulo. And so with that, I get this to go. Let me put this, take out the curve deformer, and you can see something similar to what we saw in the other applications, right? This is distributed along the x-axis. Right, so after that, let me just take this out. After that, we just then need to have the distribution that comes from the modulo from 0 to 1 to affect the rotation and the scaling. And so in this case, I have this interpolating from curve mapping. And so I did the same curve that I did, for example, here in XSI. I have this curve profile. I've done the same thing here in Blender with this interpolation from curve mapping. And I've put it on this map range, which allows me to choose the interpolation. So I had to put use interpolation to access this. And so with that, I was able, in this case, to control the scaling. So this is controlling the scaling of the pieces at at the tips. So if I take this out, notice that the path scales up. Or if I take this out from here, and I put 1, 1, 1, you notice that the size of the pieces is unchanged at the tips. So I had to put this scale in here so that they are scaled down. And then lastly, I also scale them by their velocity. And so this is the same thing that I've done on the other applications, where I have the random value, this random value that is used to affect the speed of at which the rate of the pieces are moved, to also be used to scale them. So the fast ones are thin and the slow ones are short and chubby. So yeah, sorry about this Blender thing. I really don't like. This is why Blender was the last one, because it's the one that I used the least, and to me it had the most unknowns. And actually, the worst happened. There was something that happened that I don't know how to fix it, and so sorry for the presentation be as this. It's not very interesting, but I'll share the scene files and you can inspect them, and so hopefully that will compensate for it. So let me just check the chat if anyone is alive still at this hour. And yeah, I guess there's still some people that are alive. Great. I'm gonna open up for questions. If there's some question people have, let me know now, so that it gets registered on the stream. If there's something that you think that is worth to share or something like that, let me know before I close shop. Thanks, Masiej. Yeah, thanks, Javian. I really put myself out there with this one. It had added everything to go wrong, but well, apart from that Blender blip, it didn't go that bad. And thanks for you guys for stopping by. When we put ourselves out there, we never know who's gonna show up. So yes, I'm going to contact Guinness, so I can put my name on the book of records. It's special. No, it's definitely a stunt, and I know it's a stunt. But the idea was just to show that if you can if you can grasp an effect in one place, it gets really really easy to apply it in somewhere else. And to me, like, okay, if you would give me a coding environment where I would have to type the things that I've done here, I could do it there, but I find it much faster to do mistakes in nodes. And well, yes, exactly. That's exactly right. It's about principles, and that's why I've done the Discord server, because I think we can influence each other to get, more solid principles, and that those principles will really can really help us to break down things that we want to do into very logic steps, steps that you can apply, that that you can parameterize, that you can control, and everything feels very you know rational. To be honest, uh, this is like the first setups that I've done were also messier. So the ones that I'm showing here in the stream, I already went through them, and I sort of like forced myself to put these steps out there, so that it was also very rational to talk about this. And of course, in your day-to-day thing where you just have to put things out, not always you have the opportunity to break whatever you're trying to do into reasonable steps. Sometimes you just have to move on to the next thing. But if you can do that, it's nice, because you start to understand the patterns of the things that you're trying to do, and then as you grasp those patterns, they become tools. So you can, okay, yeah, I was trying to do this in here and there as well and there as well, and things repeat. And so if maybe I can encapsulate this into a procedure, a set of steps that consistently gets me to this kind of effect. And so yeah, so if you guys have time to think, to look back things you've done, this is one consequence of it. Well, again, thanks a lot for coming. I hope you enjoy the Discord server. It's really an experiment. I want to also have people from Cinema 4D and Fabric Engine around, so Unreal. So I really hope that that how should I say, that across application sharing can really happen. I don't know. So it's an attempt. Let's see what happens, and I hope you guys enjoy the chat. And so as the name of the service says, let it flow. Cheers.